Good morning. Thank you. It's not a very good opportunity to present right after like a highlight of a presentation. So mine, I stand at the risk of, having a very boring presentation, but I'll do my best to match the energy. Yeah, so thank you. My name is Gerald Yegon, and my talk is just about how we can utilize Earth observation and remote sensing in doing the important work that you do. And I work for a company called Planet. Planet, we believe that you cannot fix what you cannot see. We are a company founded in 2009 with a mission to image the whole world every single day, and to make this world, and rather to make this change that we have, of course, going on in the world, visible, accessible, and actionable. And we do this using our satellites. We are a satellite company, basically, and we currently manage or run the largest constellation of Earth imaging satellites in the world. We have just about 200 satellites currently in space. They rotate the Earth every single day, taking images and basically making these images store a repository where now we can be seeing what is happening in the world, in the changing world. And this is basically how they are rotating. You can see we have two main constellations. These are what we call the Dove satellites. I have one satellite out there. It's just like this. They are always on. We call them like they're always on. You don't need to task them the way people tell you. When you want a satellite image, you can task it over any area. These are always on. So an image of, for example, yesterday, we have an image of the whole country or the whole world, if you like. So if you want to see what was happening, the difference between yesterday and the day before, we can help you do that because we have an archive going back to 2009. Also on your right, you can see the SkySat satellites. These are our zooming in satellites. They are like 50 centimeter resolution. So we kind of use this to monitor localized areas. So in any localized area, we can get you an image up to 7 times a day. So depending on what you're trying to monitor. And I can ask you one question of what would you do if you could see daily change of whichever it is, whatever it is that you're interested in. That question varies, of course, depending on your industry, right? If you're in agriculture, defense and intelligence, forestry, finance and business intelligence, that question varies depending on your industry. And we can all agree that planning is a cross-cutting function. It is in each and every industry. It's in every sector of the economy. So basically here we can have planners from all disciplines, and they of course relate differently to the question as I pose. But in the end, we are aligned in terms of what we are trying to achieve. At Planet, of course, we want to build what we can call a queryable Earth. If you want to know which specific mineral is in which part of the world, we can have that repository, and we believe that this is possible. If you want to look at different types of housing, you can just basically get into a repository somewhere online, ask the database, and the database pulls up the data for you. That's basically what we want to do. It's like our North Star, what we want to achieve in the next 10 years or so. It's not an easy task. Of course, we work with partners, we work with people who are in research to be able to achieve this. I hope I'm not done with my 15 minutes. Okay. I was shocked. Yeah, but anyway, one thing about Earth observation is it helps us in each and every facet of development. Think about SDGs, for example. Of the 17 SDGs, 14 of them can be monitored or supported by Earth observation. That's how important it is, and we need to find a way of mainstreaming it in our work. And one thing about, again, since I'm trying to put together all of this, Imagery, the archive I was telling you about, can help us to react. If we see someone who is trying to cut a tree somewhere who is not supposed to cut it, yesterday's image can help us. Today's image can help us to act right now. But if we use that and put it together with artificial intelligence and technology, then we are able to model and do predictive analytics and know these are trends. Based on these trends, this is likely to happen tomorrow. Yeah, so I know I have rather a deep voice, so let me try and speak louder. But in case I'm not very audible, please speak up at the back or just raise your hand and I'll find a way of screaming. Yeah? Okay, thank you. So one thing about Imagery, again, is raw data provides manual work. It's not very useful, I can say, because of the daunting task it is. So what we are trying to do is to bridge the gap, to reduce what we are calling time to value. So just moving from sensor data to build what we call analysis-ready data, and even run analytics on top that are available off the shelf. So that if you're interested in planning, if you're interested in development control, you don't need to do a 5-year engineering course in geospatial technology so that you're able to do remote sensing, analytics, and complex work, right? We can get you plugins so that you can just stream data into your environment of development control and you realize your objectives without necessarily thinking about rocket science and space technology and all of that. So that's basically what we're trying to do. One way of doing this is rolling out these analytics on top of the data, what we are calling planetary variables. Things like measuring soil water content, things like measuring land surface temperature. We are doing that and available like off the shelf globally. Automated roads and building detections. So you don't need to understand how to do the analysis. You know, we already have it done. It's a global data set, and you can do this and get the data into your workflow. If you're using ArcGIS, for example, QGIS, any software you're using, we can definitely stream our data into your environment of choice. So allow me to talk about some use cases, just to kind of put us into context and the same page. First one, of course, is planning. And I'll talk about how we can map urban growth and those kinds of things. There's a project in Dar called Ramani Huria, where we're working with the World Bank to kind of document changes in the urban space. And basically, one thing that I can note is most data sources are incomplete, especially publicly available data sets. So if you go, for example, to OpenStreetMap, I'm a huge fan, but it's incomplete. Or it takes time to be updated. So what happens is you can use that data to plan your work, and you find yourself working with an outdated data set. So you find buildings that were maybe destroyed by floods or for maybe development control purposes, and it's still on the map. So what happens is the situation on the ground has changed significantly, or vice versa. New buildings have come up, new settlements have mushroomed, but we have not been able to update our data sets accordingly. So in our case, of course, having an image of yesterday provides a good place to start. So another example is just looking at two different images. Looking at this image in Niger in 2012 and looking at the follow-up in 2023, 10 years later, you're seeing, of course, differences in terms of new settlements that have come up. That brings the question, if you're even in the utility space, you want to connect these new buildings to energy, to water. Being able to look at the trends is extremely important, but to the naked eye, you can see the change, but you need to be able to actually track which is the area that has the most change. So what is the demand in terms of water, in terms of energy? That is what exactly we need to be able to incorporate into even planning and forecasting models. Yeah. And also you can see even in scenarios like refugee camps and settlements, we're able to track how they are mushrooming, how they are growing and which trends, where they are growing towards. And this is extremely important. This is an example in Adjumani in Uganda. So in the case of Kenya, we have to think about where are people living? What's the population density? What's the building footprint density? And with that, again, we overlay with what are these climate-induced migration incidences? Why, are there scenarios that people are migrating because of climate change? And you can see that map over there on top of the other one, where we are seeing the red counties are kind of the areas that our analysis show that these are where people are migrating most because of climate change. And I don't know if it's a coincidence, because largely those are areas that are also largely pastoral communities. So maybe there's a correlation. I don't know. And you can also see when we try to ask ourselves, which regions are more susceptible to food insecurity? And lastly, which areas are more prone to disease burdens because of environmental factors? And how are these playing into now the changes that we are experiencing because of climate change and so forth? Yeah. So another example, of course, is on the realm of permitting and taxes. I know taxes are a huge topic in Kenya. Maybe I should skip this if I want to be popular. But for tax control, it's not just about like collecting revenue. There's also an element of things like being able to know where are people living or where are people constructing. Because today, yes, maybe it is attractive for the government to collect a permit for construction, but tomorrow, when you have a fire incident, the fire brigade needs to know like what's the building footprint so that they know how to evacuate you, how to respond appropriately. So without that, they'll be operating blindly, coming and trying to use the villagers, the locals there to say, oh, so how do we put out this fire? And they are the experts, but they have to ask because they don't know how your building is laid out, right? So this is an example of Poland. So like being a global company, we have datasets of the whole world. We work with different governments, including here in Kenya, and I'll show you live examples of Kenya. So I'm just trying to show boring slides of other places, and then now when it's home, I'll show you like a real world environment and so forth, so that maybe it can become more interactive. So in this example, we are able to show you how we can update your cadastre so that you can see the changes in how people are maybe trying to expand their houses. You have a 2-bedroom, and then now you've built the back so that you can rent it out, and so we're able to look at that. And even for those in the energy space here, I saw one person from Kenya Power. We're able to help you with looking at things like vegetation encroachment at a low cost, without necessarily having to fly your chopper every single day to monitor the power line. Yeah. So, and also asset monitoring. So that's how we can also work together on. Yeah. Another example, I think it's the second last, is how we can monitor projects without necessarily going to the field. So this is an example of the Lamu port construction project. When it was first starting out and when it's progressing. And even as a planner or a project manager, you're able to ask yourself, why is this section incomplete? Is it because there's a land dispute here? Is it because there is something pending, someone has gone to court? So you're able to at least respond without being caught off guard. And on water quality monitoring, I know Go Blue projects and the issue of marine spatial plans is it's a huge topic in Kenya, and it's an area that, of course, the government is very much interested in. So it's not just about coming up with a marine spatial plan. It's also about monitoring the marine ecosystems and the exclusive economic zone, and especially the marine protected areas. So with our data, because of they're not just visual, they're also like what you call surface reflectance. So you can analyze things like water quality. You can analyze things like benthic habitats, like the seagrass and those kinds of things. We're able to at least help you map that, and coral reefs as well. So you can see that example on your screen, and at least you get an idea of how that can help you. Also things like water level monitoring. Rift Valley had a case of rising sea levels in Lake Naivasha and so forth, and Baringo. And yeah, maybe we can also use other observation to look at the trends. Is it really rising, or is it just something that happens maybe every 50 years or so? So I think that's another area that we can work on. And I was supposed to be done at this point, but courtesy of my friends who were talking about elephants, I wanted to share this example of how we can use other observation to monitor algae. You see, with elephants, they are very sensitive to cyanobacteria. Cyanobacteria comes up when algae builds up in water, and this algal and it blooms basically. So this is an example of Botswana, where hundreds of elephants died, and before they could realize it's because of algae in water. Of course, it had, the damage was done, so to speak. So now we can use other observation to detect harmful algae actually from space, without necessarily going and sampling each and every water pond in a park, and do the analytics, on near real time, so that we are able to prevent such events from happening. So let me pause there, and then we can, seeing is believing. And show you some of the live projects. Like one minute, you can even start working if you feel. Yeah, so this is an example. This is Mombasa. I just want to show you like a sample image. I know some people are asking like, how do these images exactly look, and how can we use it in our work? And we have some interesting development projects running with the government in Lagos, and you can see like we detect changes. So when you build, you change your roof, you extend, and everything else, we pick it up on a weekly basis or monthly basis. This is what the government of Lagos needed to see. So we are able to run these analytics for them, and you can zoom into any area, and you can see, this is somebody that was there. You can even like view over time, and you can see when did this person actually start building here. So if you want to maybe add some penalties, but let's not do it in Kenya. I think we feel overtaxed, so let me skip that part. Similarly, of course, you can even use this data to monitor critical infrastructure. So this is Kenya's pipeline network. And you can see, like, we can pick up whenever you're building. So this can also be a case of encroachment area monitoring. So we're able to pick it up over any infrastructure. So we're able to pick these up on a weekly basis. And in some scenarios, if it's a very critical project, we can do for you daily because we have the capability. Yeah. So thank you. And also, like, this is also for Kenya, just to pick up, you want to know, like, how many people are building, where are they building? We can also pick that up. So I know it's a bit scary. You probably want to start asking questions of, where is the Office of Data Protection? But yes, that's what technology can enable us to do. So let me pause there. Thank you so much for your attention. And this is a map of Nairobi County. We also do the same for the